go. Today's objective, I can multiply polynomials. Read together, 1, 2, 3. I can multiply polynomials. So yesterday we saw addition and subtraction. Today we're continuing with multiplication. And we're still on the same concept. Tell your neighbor the concept. Polynomials. So we already covered what they are. I gave you guys that definition. We said that they're monomials or sum and difference of monomials, and we are not looking at equations. Is that correct? Just expressions and polynomials with various terms. I gave you guys steps yesterday. We don't need to write steps, or we don't need the Freire model for this one. Now check out the steps. Step 1, distribute or multiply the factor to each term inside of the parentheses. However, notice that I added this last piece. Multiplication properties of exponents. For this lesson, we are going to add, and we're going to refresh in our multiplication properties because we're looking at multiplication of polynomials. Yes? No, you have the steps. What was step 2? Identify like terms. Step 3, use commutative and associative properties to combine like terms, and at the end, simplify. Okay? So with that said, refreshing your memory with this one. Remember this, when we multiply two exponential expressions with the same base, what happens to the exponents? Add. Everybody with me? So make sure you differentiate from addition to multiplication, because this is where some of us start making computational mistakes. Okay? Here we go. Copy that, please. Okay, here we go. Pens down, eyes up here. We already know how to multiply exponential expressions, right? And if there's multiplication throughout. Remember that we use multiplication properties, and then from there we use commutative and associative properties to rearrange stuff. Remember that? Here, let me show you again. Is there multiplication in between the 6 and the y cubed? Yes. How about between the 3 and the y to the 5th? Yes. How about between the two parentheses? Yeah, so therefore there's multiplication throughout, and I said we can rewrite this as 6 times y cubed times 3 times y to the 5th. Remember that? Okay. From there, we could rearrange it. Commutative property, 6 times 3 times y cubed times y to the 5th. Remember that? Associative property, oh, these are not the same base. These are. So, what is 6 times 3? 18. These are the same base. What is 3 plus 5? 8. We add the exponents, right, when we're multiplying same bases. Are we there? Okay. So, for today, I'm going to ask you not to do this process. I just wanted to show you what we've done in the past. Okay, now check this out. Since we already know this, now we can go ahead and do our multiplication a little bit faster. Here we go. What is 6 times 3? 18. What is y cubed times y to the 5th? Y to the 8th. When we're multiplying, we're adding the exponents. Okay, once again, the rules are, if an exponential expression has the same base, we add the exponents. Is that correct? Yes? Aren't we multiplying here? Aren't we multiplying? Yes. The only thing, we're not showing the step. We're just going to the multiplication. Is that correct? All right. Let's do B. Let's do that together. What is 3 times 9? 27. What is m? What is the exponent on the m? 1. So what is m to the first times m to the second? M to the third. What is n to the second times n to the first? N to the third. And we're done. Okay? Copy this next one, please. Okay, let's do this one together. Is there multiplication throughout? Yes, so I'm going to start with the numbers. I have 1/4 times negative 12. Think about it. Don't say it out loud. 1/4 times negative 12. Let me write it on top. This is the same as saying 1/4 times negative 12. To multiply these two, I need to add a what? 1 on the denominator. This becomes negative 12 divided by 4. What is that? Negative 3. Now let me go with my next variable. I got s squared. And I'm going to multiply times s to the what? To the first power. What is that? S to the third. Does everybody see that? And then we have one more s. So this one times this one to the first gives me what? S to the fourth. Next, you're going to circle the next variable, which is t squared. And I'm going to multiply that times t to the first. What does that give us? T to the third. And now we're going to multiply that one times t squared, and that gives us what? T to the fifth. And we're done. Okay, let's continue. Copy these. Yes. Copy that. A and B. Okay, here we go. For A, 3 times 6 is 18. X cubed times x squared, that's x to the fifth. Hands if you got that. Okay, that is correct. Let's look at the next one. 2 times 5, that's 10. Do we have any other r's aside from this one? No, so I just write it here, r squared. And what is t to the first times t cubed? T to the fourth. Hands if you got that by yourself. Okay? Now, before I continue, I'm going to introduce something that we call the area model. Area model. Write it next to that, area model. And what does that mean? That we can draw a rectangle, and I'm going to write these dimensions. This one goes here. This one goes up here. Oh, sorry. This is a third. This is a third. Okay. So if this was an area, and I asked you to find the area of this rectangle, what operation are we looking at? Multiplication. So therefore, what is 3 times 6? 18. What is x cubed times x squared? X to the fifth. Do you see how it's the same as what we got here? Yes, but this is using the area model. Why am I introducing this here? Because right now when we get to multiplying binomials, we're going to be using more of this area. Okay? Any questions with this? No? Okay, do this next one by yourself, please. Okay, let's see what we got. 1/3 times 12. That gives us 12 over 3, which becomes 4. Next, x squared times x cubed becomes x to the fifth. Y to the first times y to the fourth becomes y to the fifth. And the last one, z squared times z to the fifth is z to the seventh. and we're done. Okay? Copy this next one down, please. Right there. Okay, here we go. If we follow our steps, what is our first step? Multiply the factor inside the paren. What is my factor? 4. What is 4 times 3? 12x squared. What is 4 times 4? 16x. What is 4 times negative 8? Negative 32. Are we there? So now, step 2, identify like terms. Is this like this one? No. Is this one like this one? No. Are any of them combining? No. So we're done. Yep. This is 12x squared plus 16x minus 2. Yep. Okay. Last one. Here we go. Notice this one has 2 terms inside of the parentheses. It's a binomial. And outside it's multiplied by this monomial. So here we go. My steps. What's outside of the parentheses? 6pq, and we're going to multiply times each of these terms. First, we start with here. What is 6 times 2? 12. What is p times p? P to the second. Do I have any q's here? No. For the first term, we don't, so I just write it there. Next, the same factor, I'm going to multiply times the second term. What is my coefficient here of the q? 1. So therefore, what is 6 times negative 1? Negative 6. Do I have any p's? No. What is q times q? Q to the second. Are these exactly the same as these? No. So we cannot combine, and we're done. Homework. Page 451, 27 to 43 odd. Have a good one, guys. Enjoy your homework. Turn in your homework on your way out. See you tomorrow.